All right, friends, I want to try to explain my solution key a little bit here, and hopefully it will help you. Pretty good on this first one, but you do need to see right here that if you simply add y squared to both sides and then add 64 to the other side, this is a circle. So we got a circle with a center at 0, 0, and a radius of 8. Okay, so you can see that up here. Do notice that it is a dashed circle, and I'm shading on the inside because less than means shade the inside of a circle, but also we shade the truth. So if you were to plug in 0, 0, you would get 0 is less than 64, which is absolutely a true statement. So since this point is true, you shade inside the circle. And if you check 0, 0 for that parabola, sorry, I went a little fast. Remember, the vertex form of a parabola is actually HK here. So that's 3, 4. Some of us had that vertex wrong. But it's a horizontal parabola opening to the side. And then if we check 0, 0 in this one, we get 0 is less than or equal to 0 minus 4, negative 4 squared, 16 plus 3, 19. Also a true statement. So you need to shade outside, or the region where the origin is, for the parabola. So if I shade outside the parabola, but also inside the circle, we get our little Pac-Man looking thing there. Okay, so that's the corrections to that first one. All right, this second one, we're having a really hard time just with the factoring part. So let me first just give you the good news. Circle reciprocal function. A lot of us have that. But whether you solve for x or solve for y, it doesn't matter in this one, and you plug it in. So we plug it in. Once we plug in a fraction into x squared plus y squared here, we need to get 400 over y squared, but then the next step is important. Multiply by y squared. That will get the y squareds to cancel there. It'll distribute through. And just kind of checkpoint yourself. Try to find this on your paper. See if you got that far. Okay, but the kicker is then a lot of crazy things start happening sometimes through our algebra. So I want you to see what's happening here. We have ourselves this, and then I'm going to subtract 41y squared here plus 400. So when I do that, I have y to the fourth minus that plus it, and then I'm like, okay, well, here's the thing you really got to know. By doing a bunch of these problems, you really got to, I mean, if you were like, man, factors of 400 that get me to 41, you have to have, when you factor, a minus and a minus, okay? So y to the fourth, this is literally a trinomial, and you have y squared times y squared to get to y to the fourth, but you have a minus and a minus because you have to get a plus. Two factors are going to multiply together to give me that number. You have to have either two positives or two negatives. Well, since there's a negative 41, we got two negatives. The other kicker is when you've seen these types of problems, one of them's probably going to be a perfect square. In this case, both of them are perfect squares. So we get two possible answers of plus or minus 4, and then two possible answers of plus or minus 5. Now you might be like, man, I don't see any other work. How do you get these answers? Slow down with me. Here we go. I got a y value of 4. That's this one right here. I got a y value of 4. When I took that 4 and plugged it into the original one up here, I got an x value of 5. So I got an ordered pair of 5, 4. I've paired them up. Interesting. Okay. Zoom out a little bit so you can get this. All right. So I've got those two in there. Next, I also got a negative 4. So here's my other part there. I also got a negative 4. When I plug negative 4 in, what's 20 divided by negative 4? X value of negative 5. So negative 5 pairs with negative 4. So I got two ordered pairs there. And then likewise, if you get a positive 5, and then I plug it in here, I get a 4. If I get a negative 5, I plug it in, I get a negative 4. So some of us had way too many solutions. Some of us didn't have enough, but the majority of us just have a little issue with the factoring there. Okay, so make sure you're watching your factoring. Also be careful. Flipping through to number 3 now. Pretty intense to see it all at once. Okay, so I'll block you. Okay, slow down with me here. So I personally used elimination, which I saw a lot of you do, and you got to this phase. If you multiply by 2, everything by 2, you are able to eliminate and get the y by itself. But be careful, when you take the square root of both sides here, you get y equals plus or minus root 2. Root 2, not 2. Okay? Now, watch what I did. I took this. I'm going to talk my way through this one. I took this y value of root 2. Just concentrate on the positive root 2 right now. And I plugged it into the top one. So This here went into 2xy, put in the root 2, plus y squared, put in the root 2, equals 10. 2x root 2 became that. Root 2 squared is 2, so there I subtracted 2 from both sides, I got 8. Divided both sides by 2, I got 4. Divided, and I got 4 over root 2. So basically, when I put in a positive root 2, I got an x value of 4 over root 2. Okay, that was for plugging in the first one. Now, taking the negative root 2 and plugging it in there as well, changed it a little bit, just made both of them negative. So we knew the input was negative for the y value, that is, and then we got an x value of negative as well. So I got an ordered pair of the two positives and the two negatives, so on and so forth. I then plugged it into the second one, because that's what we said. We got to plug it into each of them when they're both nonlinear like this. So when I put in a root 2 here, positive root 2, that squared to make a 2 times 3 made a 6. Subtract the 6 from both sides. You can follow my algebra here, but I got an x value of 4 over root 2 when I put in a root 2. And likewise, when you follow this through, you'll see my algebra here. I put in a negative root 2, squared it there, put the negative here, it gave me here. So long story short, when I did each of these, I got this ordered pair here, I got this ordered pair here. That means that is a solution. I got this one here, I got that one there, that means it's a solution. So there's 2 solutions to this problem, not 4. I'm just showing you, I said, or if you rationalize this, if you multiply by root 2 over root 2, that's what you would get. Okay, you don't need to, I'm just showing if you did. Okay, so I hope that helps a little bit. Now, next one, please draw a picture. Draw a picture. Too many of you are getting this equation wrong because you're not drawing a picture. It's doing x plus y. So here's the kicker. It was supposed to be rectangular, but most of you did that anyways. I will be clear about that, okay? But if you look at my diagram, I did 3 x's like that, 2 y's like that, and that takes up all the fencing. So I got 3 x's plus 2 y's equal 36. So really slow down at the beginning of the problems. Make sure you have it correct at the beginning of the problem so that it makes sense throughout the problem. Because if you get it wrong at the beginning, your equations are going to be out of whack. So we got 3x plus 2y, and that's the perimeter. Right there's the perimeter, not the perimeter, but the amount of fencing you have. Okay? And then the area, x times y, would be the whole area there, and that was supposed to be 54. Well, this becomes very similar to the one we did on the front side, except it's not to the 4th power, because now I have, and you can solve this for x or y. I solved it for y, and then I put it in here. So I had 3x plus 2 times 54 over x equals 36. Be very careful. I saw a few of you do this. The 2 is really 2 over 1. So the 2 does not go to the top and the bottom, just to the top. And then, I didn't show my work here, it looks like, but if I multiply this by x and distribute that through, multiply this side by x, we get that next step. And then this is solving a quadratic here. Okay, so 3x squared, bring the 36x over here, plus 108 equals 0. I did notice right away that there's a 3 that goes into everything, and if I have a 3, I am definitely going to take everything out. I'm going to divide everything by 3. And then this one, I don't know if I had a little trouble when I did that or what, but x minus 6 times x minus 6 equals 0. So it looks like only one possible x value here, because this was a perfect square trinomial. So what's the possible x value? 6. And if I put a 6 in here or a 6 right here, I'll get the y value of 9, but that would stand for the dimensions, which totally makes sense based on the problem. Okay, so hopefully that helped on that little skill check there for you.